Welcome students to Unit 2. In this unit, we're going to be discussing how to organize and summarize data. And in this particular video, we're going to be talking about tables of data and graphical displays of data. Our focus is also going to be on qualitative, otherwise known as categorical data. So let's begin. What I want you to do before I launch into some examples and terminology, I want you to take a moment and pause the video and look at this set of data that is actually obtained from this class. Now, these are the degree programs in which the 28 students taking this class are currently enrolled. You are also on this list as an individual. Take a moment to summarize and organize this data in a way that makes sense to you. And once you're done doing that, you can unpause the video and return to the following examples. So take a moment, pause it here, and I'll see you in a few minutes. Okay, welcome back. So I'm going to walk you through some examples that perhaps mirror some of the things you just did with the data set that I gave you. So one thing that we want to do is we want to know how many times something shows up in a list. And the way we do that is through a frequency distribution, which lists the category of the data and the number of occurrences it appears in the data. So what does that look like? Let's take a silly example. Let's suppose there was a survey and participants were asked, if your friend threw you a party that became inappropriate, would you tell your fiance all, edit the details, or say nothing? So this is a moral dilemma, but for the purposes of this course, let's make it a statistical dilemma. So suppose we obtain the following data. Now this looks similar to the list I gave you previously about degree programs. What I want you to do is think about how you organized it and then see how I organized it. So in statistics, what we can do is we look at all of the different categories. In this case, we see tell all, edit details, and say nothing as the three different categories that appear in the data. So we're going to put that in the left-hand column. And then in the right-hand column, we're simply going to add up how many times it occurs. So here you could see tell all. If you counted all of the tell all boxes, you'd find there are 14. Edit details, there are 7, and say nothing, there are 4. And if you look, it's 5 across the top and 5 down, which means total, we should have about 25 data points. When we add up the frequencies, we should also get 25. And in this way, we know we counted every piece of data from all of the individuals that were surveyed. All right, now what can we do next with this information? We could also create a graphical display. What that looks like is a bar graph is one option. And that is constructed by having the vertical axis be the counts of the individuals, and the horizontal will be the categories for the individual data pieces we collected. If we have a Pareto chart, all that is a fancy term to say that the bar graph is in order, where the tallest bars are on the left and the shortest bars are to the right. So let's take a look at this example. For party secrets, we have tell all being the highest, we knew at 14, edit was at 7, and say nothing's at 4. So as you can see, we have the categories along the bottom, tell all, edit details, and say nothing, and we have the frequency counts going up the vertical axis. Also important to note is that the vertical axis, where the numbers are, goes up at a consistent scale. What do we mean by scale? It means that from one line to the next, we increase by the same amount. So from 0 to 2, there's 2. From 2 to 4 is also 2. 4 to 6 is 2, et cetera, et cetera. And this way, the graph clearly represents the data and isn't incorrectly portraying the data. This is really important, and you'll see a lot of incorrect graphs based on incorrect axes, such as this, where the scale is off or they start at a weird value. So keep your eye out for those in the news. We could also represent this data as a pie chart, and a pie chart is a circle divided into different sectors. And each sector shows you how much that category shows up. So if we were to draw a circle and look at party secrets, we know tell all is the biggest amount. So that should be the biggest chunk of the circle or the pie. Think of it as pizza. It'll be a lot of slices that are dedicated to tell all. So here we have that display. Now, as you can see, this also represents percents of the data. So tell all was 14 in terms of the number that we collected, but 14 out of 25, which could also be written as 14 divided by 25, gives us the 56%. Same with edit details and say nothing. If you divide both of the frequency counts, the 7 and the 4, divide by the 25, you'll get those percents. That's where those values are coming from. Let's look at another example. In this example, we're looking at two groups simultaneously, but we're still looking at categorical data. So in 2010, there was a survey of adults and teens to determine the number of texts sent in a single day. I'll pause here and let you make a hypothesis about who you think texts more. Okay, so let's look at the results. So when we count up how many individuals in each of these groups texts, the number of texts listed. So if they don't send texts at all, that number is at the top. You can see 173 adults do not text versus 13 teens. A few means they sent 1 to 10 texts in a given day. Some is 11 to 20 texts. Average is 21 to 50 texts. Many is 51 to 100 texts. And a lot is anyone going crazy with about 101 or more texts. Think about how many texts you send in a day. Which category would you fall under? Now, if we look at these categories, it can be a little confusing because a lot of adults were surveyed and not as many teens. So this might make it harder to interpret the results because every single category, the adults are higher in, except for the very, very last one. But because we surveyed more adults than teens, this is not surprising, and it's also not helpful. We don't really know who texts more if we have a much larger population in one of the groups. Luckily, in statistics, there are ways around that. What we can do is we can do a side-by-side to look at it. That didn't help us. Remember, a bar graph only shows the frequency on the vertical axis. So this is saying the same thing that the table said. And what we notice is, again, in every category, adults are higher except for the A lot category. So what can we do to fix this? In comes relative frequency. Relative frequency allows us to look at the frequency in relation to the number of people surveyed, which means we can actually figure out the percent of people in each category, and percentages we can compare because all percentages are out of 100% or the total group. Let's see this amazing tool in action. So the relative frequency is calculated by taking the frequency and dividing it by the sum of all frequencies. In this case, it'll be the frequency of the adults in that category divided by all of the adults. And we can do the same thing with teens, where we look at the frequency in that category for teens and divide it by all of the teens. So here we go. If we take this table and complete the relative frequencies, we'll get the following. And if you want to test this out, pause here for a moment and take the value of 173 and divide it by 1,936 to see that when you round, you would get 0.09 for the adults. You can calculate each and every one of these decimal values the same way that I just mentioned. Again, you could also test for teens. The teen calculations are going to be different. It'll be the 13 divided by 627. So take a moment and pause here and try to calculate all these values and see where they come from. This step is really important to understanding relative frequencies. What's even better is now we have a graphical display that'll show us this relationship. So we're going to return to those side-by-side bar graphs, but the vertical axis, instead of being counts, is going to be percentages. So here we have 0% all the way up to 60%. Again, the vertical axis has a scale that's consistent. Each line represents 10% more. Note that 0.10 is a decimal representation of 10%. So they are equivalent. Now we see some interesting things happen. The none and a few categories still have the largest portion of adults versus teens. But as we move into the higher level categories, the results start matching what we thought at the beginning, or at least what you might have hypothesized, that teens are more prone to text than adults. So if you look specifically at average, many, and a lot, you see this behavior switch from the bar graph above. If you don't remember, take a moment, rewind the video, and check it out. This relative frequency bar graph is much different than the frequency bar graph. When comparing two groups, it's really important to consider relative frequency over frequency, especially when the population surveyed differ dramatically. Now, I hope you had the opportunity to try out all of this with degree programs. If you still haven't tried out these methods with degree programs, or you ended up with a different method, take a moment now to try out the methods we just described for the degree program data that was at the start of this video. Be sure to pause this video, try it out, and then I'll walk through this example. So here we go. For degree programs, let's look at the distribution of degree programs by summarizing the data. Again, we can do that by taking all of the data and converting it to counts. You may have noticed nursing is the most common degree program in this course. So welcome, nursing students. Criminal justice also is in second place, but all of these degree programs are very important. And also, statistics is very important for these degree programs, as you'll see when we get into different data sets that match your focus. So hopefully you have a table that's similar to this one. And of course, the bar graph, in this case, since we're not comparing two different populations, either the frequency or the relative frequency bar graph works. In this case, I used a Pareto chart. And the reason for that is I wanted to know the most common degree major all the way down to the least common. In this case, a pie chart wouldn't make a lot of sense because there's a lot of different categories. Let's look at relative frequency, even though it'll be the same display as we just saw. This is just good practice. So for the relative frequency, here we have the nursing, which is almost half the class. So relative frequency really lets you know how big the population is for that degree program. So in this case, nursing has the bulk of students. The other ones have much lesser percentages than nursing. So again, as I said, a bar graph is great for looking at the specific degree programs, but wouldn't be really useful for a pie chart. So what I did to have some pie chart practice is I converted all of the degree programs to the degree program type. So for the AAS, which are the nursing, the early childhood, rad tech, game design, and office technology, I combined all of those as AAS degrees. And that came out to 19. I combined all the AA degrees, criminal justice and liberal arts, and that gave us a total of 6 AA degrees. And I combined business management with accounting for forensic accounting, and that gave us a total of 3 for the AS degrees. And here I've included in this pie chart the label, as well as the percents and the frequencies. So you could see all of that information in this pie chart. I hope that this was helpful. That's it for this portion of the unit. I hope these examples were helpful. Please reach out to me if you have any questions about qualitative data. I'll see you in the next video.